Dear students, I am R. Vijayalakshmi, Assistant Professor EEE, Nanda Engineering College. Now I am going to give introduction to power electronics. First, what is power electronics? Actually, power electronics means the power engineering consists of power generation, transmission, distribution. The power equipments are controlled by using some of semiconducting devices. That is, power electronics deals with the conversion, control and conditioning of electric power using some power semiconducting devices. It also bridges the gap between electronics and power systems. The block diagram shows explaining the input power, that is source is fed to the power converter. The power converter converts the power from one form to another form, like AC to DC or DC to AC. Then it is fed to the electric loads. Okay, the controller is also connected between load and the converter itself. Why? Because the controller getting feedback from the load and comparing with the reference signal and given to the power converter. Then the power equipments like static or rotating machines such as transformers, alternators, generators, motors, all the power equipments are controlled by small power electronics devices. Like the control is based either analog or digital. The types of converters in power electronics. The power electronics converters are classified into four main types. AC to DC converters called as rectifiers. In this has two types. One is diode rectifier. It is uncontrolled rectifier. That means the fixed AC voltage into fixed DC voltage. Then the second type is phase control rectifier. It is the device used for this as SCR. It converts fixed AC into variable DC. By the firing angle, the output voltage can be controlled and varying, so it is called as phase controlled rectifiers. Basically, the rectifier used diode is called as uncontrolled rectifier. So used device as SCR is called as controlled rectifier. Then second type of converter is DC to DC converters, that is fixed DC into variable DC converters called as choppers. And third one is DC to AC converters, that is called as inverters. Then last one is AC to AC converters. As we know, the AC quantities are voltage and frequency. If you are going to maintain voltage are constant and frequency is going to varying, that is called as cycloconverters or frequency changes. That means fixed frequency into variable frequency. In next case, the frequency is maintained as constant, voltage is going to varying from fixed AC voltage into variable AC voltage called as AC voltage controllers or AC voltage regulators. So, rectifiers, AC to DC. Then historical background. In 1900s, mercury arc rectifiers were introduced. In 1957, introduction of silicon control rectifiers. It's very well known, SCR. 1970s, power BJTs and GTOs developed. In 1980s to 1990s, the IGBTs and MOSFETs were introduced. Presently, the devices are used for high frequency systems are SiC and GaN is nothing but silicon carbide and gallium nitride. These devices are called as wide band gap devices. Initially, the gas tube electronics was there. After that, the next version is saturable core magnetic amplifier. After that only power semiconductor electronics modern era occurred. In that has four types of generations: first generation, second generation, third generation and fourth generation. In first generation, thyristor era was introduced. Thyristor is nothing but SCR. In second generation, self-controlled power electronic devices such as BJT, power MOSFET, GTO. In third generation IGBT, that is insulated gate bipolar transistor. It combines both BJT and power MOSFET characteristics. In fourth generation, the new devices introduced as ICGT, CoolMOS and SiC. Then importance of power electronics are, it is mainly used for power conversion in high efficiency, compact and lightweight systems. It also crucial for renewable energy and microgrid integrations. It also play a key role in electric transportation and automations. The various applications of power electronics, mainly it is applicable in automotives and tractions like subways, hybrid electric vehicles, forklifts. In industries, rolling mills, elevators, pumps, cement mills, construction machineries. And in renewable energy, it is used in solar PV systems and wind energy systems. In defense and aerospace, satellites, space shuttle aircrafts. In utility systems, smart grids, fax and HVDC transmission systems. In our day-to-day daily lifestyle, vacuum cleaners, UPS, computers, air conditioning, and also modern traction systems, ships, electric power sharing in automotives and tractions. So power electronics is in various domains. The main power semiconducting devices are diode, it is uncontrolled device, SCR, it is semi-controlled device, BJT, it is current control device, MOSFET, it is voltage control device, moreover it is very fast switching device. IGBT, it combines both BJT and MOSFET. Then our current devices, SiC and GaN, it has high speed and high temperature operations. The comparison between the devices are the diode uncontrolled device. All the devices are SCR, MOSFET, IGBT, SiC and GaN are gate has the gate terminal. It is control terminal. So these terminals are all have a gate. Then speed is diode fast speed. Voltage rating is very low. Application, the mainly diode is used in rectifier circuits. It converts fixed AC into fixed DC. In SCR, the speed is medium only. Voltage rating is high. It is also used in rectifier circuits. It is controlled rectifiers. In MOSFET, speed is very high. Voltage rating is low and medium. It is mainly used in DC to DC converters. Then next device is IGBT. It is medium speed. Voltage rating is high. The applications is mainly it is used in inverters. Then SiC and GaN, it has very high speed and voltage rating also very high. Then application is high frequency converters. Thank you.